Newton's first law asks what happens when there is no force acting on an object, and the answer is inertia. Newton's second law asks what happens when there is a net force acting on an object, and the answer is acceleration. To be more exact, the law says that acceleration is equal to the net force someone puts on an object divided by the mass of that object. So here's an object, and here's someone who can apply some force. Even though this is a baseball, we're going to put an M for mass on it, because mass is a huge part of this second law. We're going to call the net force the pitcher puts on the ball F, and when the ball leaves the pitcher's hand, it moves with A for acceleration. I'm giving the pitcher the ball, which again is the mass. He's working up some force to put on that mass. Nice pitch, dude. All right, let's get the bowling ball out here. So let's say you put the same amount of force on the bowling ball. What's going to happen?
My arm's gonna fall off?
Ha, no. You're going to put the same force on the bowling ball as you did on the baseball. So that's going to affect the acceleration, right?
Okay, whatever.
Let that force rip, same as before. The bowling ball didn't go as far. Its acceleration dropped, even though the same force was applied to it. Same force, but 50 times the mass. The acceleration drops a lot. Let's write it out. That awesome acceleration you achieved with the baseball, you got that acceleration by throwing the baseball with your net force. If that's a math equation, you're actually dividing the net force you put on the ball by the mass of the ball itself. Then, that not so awesome acceleration you got with the bowling ball, you got that by applying the same net force you put on the baseball onto the bowling ball, which has a mass that is 50 times greater than the mass of the baseball. So if you take the 50 out of this side, you find, yep, the acceleration from the bowling ball pitch is 1/50th the acceleration of the baseball pitch, much slower. That's Newton's second law in action. Acceleration equals net force divided by mass.